Today I want to talk about textile recycling and technologies and potential from the perspective of the automotive industry. And I'm quite sure you're very familiar with the textile industry, companies there. Maybe Volkswagen as an automotive OEM is a bit exotic in that place, so I would like to introduce Volkswagen very briefly with only a few numbers. So the Volkswagen Group, back in 2022, we had about 325 billion euros in sales revenues, resulting in an operating result of 19 billion euros. We delivered roughly 9 million vehicles globally with our brands and had 680,000 employees. So these were the numbers from 24. When I put these slides into our publication process, we didn't have the numbers for 25, but essentially only two numbers changed. So the operating result is now at more like 10 billion euros, split in half, and the number of employees decreased a bit to, I think, 660,000 people, but we still delivered 9 million vehicles. And I think that number is quite impressive because it represents around 25,000 vehicles each day of the calendar year that are getting produced and then delivered to our customers. Now we zoom a bit in to the part of the company where I'm working for, and that is called the Volkswagen Group Innovation. So formerly it was called Group Research, and that's basically still what we do. We provide research, insights, technical results for the brands within the Volkswagen Group that we have. You can see the brands on the right-hand side that are clustered in different groups. We have the brand group Core, that represents the brands with a high volume of vehicles. We have the brand group Progressive and Sports and Luxury. And the Volkswagen Group Innovation is located with a center here in Wolfsburg, also where the center of the whole group is located. But we have innovation centers and hubs all around the globe. So we have an innovation hub in two, basically in the US. We have one in Tel Aviv, also a new one in India, in Pune, and one innovation center in China, in Hefei. And all these hubs are also doing research with a different perspective depending on the market where they are located. Okay, and this is basically where I'm coming from, and this is why I present now some of the research topics that we cover in the field of textile recycling. So what is our motivation as an automotive OEM to take a look at textile recycling? I mean, the numbers on the left-hand side, I think you're quite familiar with that. And we've also seen in the earlier presentations that these numbers are not going to decline. They are more getting to, they are getting higher and higher. So the waste stock that we have is tremendous. If we look at the fiber production, we see that there's roughly 120 million tons of annual fiber production. And we've heard about that earlier. Roughly 3/4 of them currently are getting incinerated or landfilled somewhere. And if we take a look at the composition of these fibers, we can see that roughly half of it, and that amount might also get higher in the future, half of that is polyester. That means the amount of polyester that is ending up here in the moment, for you to give an imagination, that is 10 times the whole plastic consumption of the Volkswagen Group, roughly. So really huge waste pile. And we've also heard about the legislation that is coming for the textile industry, but the automotive industry has also regulations that we are facing. I'm not sure if you're familiar with that, but we have the EU end-of-life vehicles regulation that is upcoming. And that will force the automotive OEMs to incorporate a certain recycled content for the plastics that they use. And that comes in two steps. So from 2031, 2032 onwards, we'll have to incorporate 15% of post-consumer recycled plastics in the whole vehicle. And from these 15%, 25% has to be closed-loop recycled. That means from end-of-life vehicles. And a few years later, the numbers will rise to 25% post-consumer recycled content. And sorry, I missed that number. 20% has to be closed-loop recycled content. And also another important point is that these quotas are relevant for homologation. That means if you don't reach these quotas for new vehicles that you want to place on the market, you're not allowed to sell the vehicle. It's not that you pay a penalty fee or something, you are simply not allowed to sell the vehicle in the EU. Yeah. It's a very strict regulation that is upcoming. And now a small calculation. as an example here. So a current battery electric vehicle has roughly 320 kilograms that are relevant for that regulation. And that means we have a post-consumer recycled demand of 80 kilograms and a demand for closed-loop material of 60 kilograms per vehicle that we have. And question is now, how do we get that post-consumer recycled content into the vehicles? And this is where textile recycling is also getting interesting for us. We have that quota over the whole vehicle, and that means we have to find different combination, different suppliers, market structures to get that post-consumer recycled content in our products for an appropriate price with the required quality and longevity that we still have. And automotive products have to be very robust because they're in use for like 15 years, 20 years, and especially the textiles are heavily used, and they need to be really, really long-lasting. So, and if we take a look at the general pathway for recycling of textiles, you're also quite familiar with that. We have the collecting that is now getting an importance. Then we have sorting, more and more automatical sorting systems upcoming. And depending on the material composition, there are different pathways that we can follow. And important for the different combinations that we take a look on is that I'm personally, or Volkswagen, is only interested in the polyester content. Yeah, recycled cotton is good, sustainable, but it doesn't help us with the quota because it's not a plastic. Yeah, so I'm only interested in technologies where we can the polyester get back from even mixed textile waste. And then depending on the polyester content in this in the waste feedstock, there are different pathways that we are currently following in research projects and with partners. First feedstock, or first pathway is currently quite available, is we take a purely PET, purely polyester sorted fraction, put that through a tearing process, we end up with the polyester fibers, yeah, the fiber pulp, and we can mix that again with some bicomponent copolyester fibers to be able to, in a deep drawing process, produce parts like that. We'll show that later on. Other pathways with a lower PET content but still high can be chemical recycling, where we get new PET fibers in a virgin-like quality for certain applications. And the big question mark is, okay, what do we do with the huge amount of feedstock that has a low polyester content? And I'm only interested in getting the polyester back. And there, a quite interesting approach that we see is the enzymatic purification. Please do not change that with enzymatic recycling of the polyester. It's a different process, where we have the PET fibers as kind of leftovers. I'll explain that later what that means. And these are the different pathways that we're now following with our with different partners in research projects. And yeah, coming to the first approach, this is something we already did a few years back then. The first approach for the demonstrators, we decided to go for the parcel shelf, in German Hutablage, in the car, in the back of the car, and the trunk side trim panel. And what we did here together with partners and even a tier 1 supplier that is producing the Golf components here is to tier a sorted polyester textile fraction. We decided to go for a black here. And you can see here what the outcomes of that process were. So here you can see the removed buttons and zippers, everything that is removed during the tearing process. You can see here the fiber mass, also some imperfections that still come from washing instructions, imprints, and so on. And with this material, after blending it with other fibers like bicomponent copolyester fibers, we produce rolls of non-wovens and put these in a thermoforming process. And these are the current photos of the parts. And you might wonder, okay, these look very normal. This is because these parts usually are multi-layer parts. And what we changed is the carrier layer of these parts. This is why you can see here the carrier layer of the parcel shelf, which contains also some glass fibers. Here you can see the textiles, or quite impressive, you can see the imperfections on the back of that part here. We also did some testing. Most of the requirements could be fulfilled, so there's still some development that needs to be put in this direction here, but we also want to focus on the other pathways that we can utilize. And the next pathway that is quite interesting for us is the chemical recycling. Just a short reminder, what does chemical recycling mean? We have the used textiles with the polymer chains of the polyester contained in that, and that runs through a depolymerization. So you end up with the monomers that can be repolymerized to get a virgin-like polyester material that can go through the whole production chain, like business as usual in the textile production industry, through fiber spinning, textile production, and we end up with a new textile. And here, with that approach, we did a proof of concept together with the company Syre. And for that proof of concept, we produced a seat cover with an existing weaving pattern. You can see that here. That was produced completely with tiers that we already have in the process chain. So everything from repolymerization, yarn spinning, textile weaving, and producing of the final seat cover was done with existing partners already. You can see the final product here on the right-hand side in the picture, and the seat is also for you to experience at the booth of Syre. Right here outside the door, you can see the actual seat, and you can touch it and get a feeling for that. And also something that we did here in that approach is we used a PET non-woven as a backing for that seat cover. Because for us it's not only important to use recycled content in the products, but we also are trying to get the products more and more recyclable in the future. So we are switching to monomaterial approaches here as well. But again, the black part that was produced with the Syre material from chemical recycling, this I think that came from bottle flake rPET here, but it's a monomaterial part. And another interesting approach, another interesting aspect of the approach of chemical recycling is the capability of recycling the automotive feedstock, and that is really challenging, I can tell you, because current textile parts in the automotive industry are usually mixtures of different fibers, glass fibers, polypropylene fibers, polyurethane foam, and so on. So very complicated to recycle, and we kind of gave that Syre here as a challenge. So I handed them over the offcuts from the first products that we've seen from the mechanical recycling part, and this is PET fiber, PP fiber, glass fiber, copolyester bicomponent fiber, everything mixed, and I was asking them to recycle that, and they were actually able to do so. So all of the polyester in that part here was depolymerized to the BHET monomer that could go in a reproduction process. Same for some seat covers that we have that are PET textile with a polyurethane foam backing. Also here that could be completely be depolymerized to BHET. Okay, now coming to the third approach that I would like to explain to you, and I already mentioned it, it's called enzymatic purification. It's not an enzymatic recycling process. And here we are collaborating with another company, startup Refresh Global, because I think the approach that they follow here is quite unique and for us very promising to get economically feasible the polyester fraction from the textile waste with low polyester amounts. And yeah, they use enzymes. The enzymes that are used in this process here are called cellulases. That means they split up cellulose-based polymers. Yeah, and depending on how long you run that process, under which conditions, these enzymes split up the cellulose to either nanocellulose or glucose, sugar. You can produce then bioethanol from that. And from our perspective, these are byproducts, but they have a value on the market, and they can help to finance the whole process, as I'm then only interested in the kind of leftovers, which is the PET or the synthetic fiber fraction here. Yeah? And the same cellulases, the same enzymes are very specific to the polymer that they react to. That means if a cellulase just sees a PET polymer, there's basically nothing happened to it. Yeah, and with these fibers here, they stay in shape, they keep their color, they keep their shape. You can go into different processes again, produce non-wovens or even staple fibers, and then produce different textile applications from that. And that is something we were also trying in first initial trials. We took a sorted fraction again, but mixed textile waste, so the color also stays the same. mixed that with bicomponent copolyester fiber, and depending on the process parameters, you can get different mechanical properties, different appearances of the parts. And in the next step, we also took that on the next level by scaling that up to a ton of material. And you can see the initial feedstock here. So we went again for a black sorted pile of material with a composition of 60% PET and 40% cotton. And that was put after a tearing process through the enzymatic treatment. You can see the mass balance here. So over the treatment process here, this is the mass loss after the enzymatic treatment. So we mainly have polyester then left after that process. And with that, basically, we did the same parts as in the first approach, mixing it with other fibers. And we produced the trunk side-trim panel again on the series production side of the Tier 1 supplier in the series molds, so with a series process. And also these parts here worked quite well in testing. Also different few things that need to be addressed, but I think it's quite good doable in the future with a bit of further development here. Okay, and the last thing that I would like to show you that's also possible with that pathway is, again, have the cut textiles, tiered fibers, and then after the enzymatic treatment, if the fibers are long enough to go into a staple fiber production again, or a yarn spinning process again, and then we show that it's also possible with this material to go into another weaving process and to get a textile that is also suitable for some applications in the automobile. Yeah. Okay, that was it from my side. If you're interested to get in contact, you can email me or we can get in contact here at the conference. I'm also here the next 2 days, so feel free to get in contact or ask any questions that you would like to ask.